Okay, 34. A lot of stuff to do on this one problem, but it's a good question for that reason. So we've got customers waiting for a table at 6 o'clock on a Saturday night. Oops, let me get a marker on my pen here. 6 o'clock on a Saturday night. Get this. For 40 consecutive Saturdays. So on one Saturday there was 11 people, the next Saturday there was 5, next 11, 3, 6, and so on. Okay, so data discrete or continuous? It's discrete. Why is that? Because you could have 0 or 1 or 2 or 3, but nothing in between those values. 4 all the way up to however many people could possibly wait, but it's only those fixed numbers in between. You can't have anybody in between. So the number of people that wait is either a finite number or it's a number that you can count. Okay, so that's discrete. Frequency distribution. Well, we just want to keep track of or figure out how many people were there and how many times were each of those values were they there. So we start at 3. Let's see, customers and counts. And we're actually going to do percentages also. So there were 3, 4, 5, 6, 7, 8, all the way up to 14 customers. So how many times were there just 3 waiting? Whoops. So we've got 1, thought I saw 2 right in front of me. So 2 times there were 3 customers waiting. In fact, I'm going to do it like this in case I miss one. So I'll just do tally marks. How many times were there 4 customers waiting? 2, 3, 1, 2, 3. So I'm going to pause and do the rest of it. Okay, so there's all the counts, and then now we're going to go ahead and do the percents. So since there are 40 Saturdays, the percentage is going to be 2 out of 40, 3 out of 40, and so forth. So 2 divided by 40. It's going to be 5%. 3 out of 40 is 7.5%. 7.5. 5 out of 40. 12.5. So I'm going to actually not write the percents here. So we got, what do we say, 5%, 7.5, 12.5, oops, 7.5, 12.5. I'm trying to do everything small so I can fit it all on this one screen. 4 out of 40 is, of course, 10%. 8 would be 20%. 10, 10, 10, 0, 5, and then 2.5%. Okay, so there's our percentages. Erase these. So this is our frequency distribution and our relative frequency distribution. So those are just tables that tell us what's the frequency and what's the relative frequency. What percentage of Saturdays had 10 or more customers waiting for tables at 6? 10 or more. So 10 or more would be this. 10, 25, 27.5. So 27.5 percent of the time had 10 or more. Percent of the time had 10 or more customers. And the next one was how many had 5 or fewer. 5 or fewer would be, it's at 7.5 times 2 is 15, 20% of the time. Or 20% of Saturdays had fewer than 5 customers, or 5, than 5 customers. Okay, does that make sense? Okay, make a frequency histogram. So now I'm going to make a histogram of this. So the histogram is going to look something like this. We'll come across here. And on this side, of course, we have counts. On this side, we're going to have number of customers waiting. At 6 o'clock. And we have to figure out how wide of classes do we make. Well, 5 to 7 classes, more classes is better. It always depends on how much data we have. We have 40 pieces of data, and we're going from 3 to 14, so that's 11. So if we go as high as, say, 7 classes, that's going to be 1 4/7, which if I round up, we always round up, that's going to be 2 wide. So let's do classes of 2 and see what that looks like. Now once we get on our calculators to do this, this becomes really easy to do, as we'll see in class next. So I'm going to do class widths of 2. 3, 5, 7, 9, 11, 13, 15. Okay, so it's going to be 1, 2, 3, 4, 5, 6 classes there. If I go that route, and it goes down to 6 because I rounded up to 2 is why it's fewer than actually 7 classes. That's just kind of a ballpark starting place. If I went 1 4/7, then it would give me exactly 7 classes. So I round up, that's why it's fewer. So that's just kind of this just gives me a get close starting place. So let's go with 10, 5. Hopefully that would be about right. So first class, 3 to 5. So that's 3 and 4, so that's going to be 5. And then 5 to 7 is just 5 and 6 because the 7's in the next one. So 5 and 6 is 3, 5 is 8. 7 to 9 is 7 and 8, so that's going to be 8 plus 4 is 12. 9 to 11 is going to be 8. 11 to 13, so 11 and 12 is 4. And 13 to 15 is 3. Okay, there we go. And the relative frequency histogram of the data is going to look exactly like this, except we're going to make it in terms of percentages. So on this side it's going to be percent. So I'm going to actually, since it's already getting up there in time, I'm going to do something like this and say relative frequency is percent. So you would change this side to percentages. The class widths would stay the same, only this scale changes, and these up top here would now become percentages according to your scale over here, which would start at 100% and so forth. Okay. And then the last question, describe the shape of the distribution. The shape right here, it's definitely H is unimodal. If you said it's symmetric without this guy over here, absolutely. It's fairly, we like to use words like that in statistics. If you said slightly skewed right, that would be okay. Either one of these is okay. As long as you're not saying it's definitely one or definitely the other, I'm okay with that. Alright, there you have it.